Sir, good morning. Are you speaking?
No, I'm just waiting for people to tell me good morning because when you come and see me, I don't know, say nothing to me. I mean, wait.
Morning, sir.
Morning, sir.
Good
Morning
morning.
all, morning
Good
all.
morning. Good morning. Good morning. All right, we are only just 5 here. Um, Wait, you there too? Pen,
Morning, sir.
have you up?
You have me have you up, but if you show me I
Mm,
go to church, me not me have something there.
No,
Me
well,
try
guess
put
what?
you down.
Me I go to church tomorrow,
Me I
so
go
me
to
can
church
have you up
tomorrow, so
today.
me I put you down because on the
No,
street,
well,
yeah, on the
because what?
street
Tell
we
me, cause
like
what?
say I play when I play
Jesus
with
have
people
mercy.
money, you know. And me
No,
not do
listen, no,
over that
you,
course here, man.
you start, me and you have a conversation, so you start plural me up and I call me uno. Me no business
Sir,
where you and excess I have.
oh, sir.
And me and you know different now. So make me tell you me have you up for. You have me up for you use my days for to fry me. But me have
Where
you up
for?
because where did they last night?
Last night I what happened last night.
Same thing. That means I have up good. I have you for a good cause then.
Last
Can
night I
somebody tell
was
last
I
night you
did
was what?
log
Tell me.
on, but my sir, I was at church last night.
Okay.
Yeah.
So you know, think when I tell me say, sir, me there at church, I praise up, and me can't come to class. We have
No,
good,
I
good.
logged on, for the starting.
Yeah, but me not see you. I mean, I ask for you. Me I ask for you. And nobody not see you. I mean, I ask for you. So that's why I have you up.
Oh, put me down, please.
All right. Romain, you know, so me
Oh,
have, go ahead.
somebody named Candice Darling.
That's my baby.
Okay, that's my best friend.
Yeah, you idiot, man. Candice can be your best friend. That's my baby.
That's
All
my
right?
best friend. So just
No,
no
man.
stay
Candice, a man.
complain.
You know, Candice, a my baby, man. You can't complain to me about Candice, but nothing on Candice believe. And my baby that. No,
Alright,
man.
sir.
Small worldy.
That's very small.
Small world. Candice is my little baby, man. Trust me. Bright girl. I'm pretty. All right.
Sir, you have some more name to send over to finance.
For the what? For the override?
Yeah.
Yeah, man. I brought the computer that I can get onto the VPN to do it now, but recognize that I didn't carry my inverter, so I don't have any power. But where I'm at now, I'd have to go beg little power to do the stuff. And I know, let me just. But then again, no, them not coming on this side now. What time now? 10:05. Because let me see if I can make a call. So I brought the computer. There's only one computer that I have that can do this stuff, the VPN. All right, let me just make a telephone call to see
Sir,
if I
well, I'm
can.
not sure. It's just that I saw persons in Mrs. Francis class asking about your class. So I'm assuming that they should be in your class as well. I'm not sure.
No, no, no. Her business calculus class is different from mine.
That's what I'm saying because that's why I didn't even bother to share the link in her group because it seems like a lot of confusion going on, or they're not understanding exactly what your class is about.
Right. So one student from the class, however, reached out to me to see if they can come and sit into my class this morning, and I have absolutely no problem with that. But yeah, it's two separate classes. This class is really moving faster than Mrs. Hall Francis' class because we are doing exams. I don't know when. Up to yesterday, I begged them to make the exam be in November, the first week of November. But we are doing exams a month before Mrs. Hall Francis students. So we are going to be moving faster. But if they want to come in and sit in, Mrs. Hall Francis and I, she's my sister. So we'll move pretty close. So I don't have a problem. But yeah, but it is, yeah, you're correct though. This is a different class. So let me just make that announcement, should in case somebody's here, um, that, that is from her class. So the conversation is this class that I'm currently now in and that you're in is a class set up specifically for those students who are doing the block scheduling business calculus at the end of October or the first week of November. I'm hoping the latter is when we're going to be doing the exam. The last time I did the block scheduling, the exam was on a Friday, the first of November, some 2 years ago when I first did the block scheduling for another course. So Mrs. Hall Francis it's a separate arrangement. It's a totally separate arrangement. And you know, the truth is I am moving much faster, students. So those of you who are not in the block scheduling group, there are students here who will have to get up. Last week, Wednesday, we got up before 5 o'clock so that 5 o'clock we could be in the class. So we're having a 5 a.m. class, and before class ends today, we need to agree which days, notice I never said day, but which days next week we're going to get up early and do some early work. Last time we did only 1 hour, and the truth is it felt good for me. We did go work, go sleep still, but anyway, it felt good for me. But if we can just get up and maybe do an hour and a half for maybe 3 days, or we do 2 hours for 2 days, at least we can get in 3 hours in the week, plus the Friday, plus the Saturday, we should finish the syllabus. All right? So if you're in Mrs. Hall Francis class, in the evenings, this is not the class for you. However, I'm not going to run you out. Sit down and go and learn something so when she reach it, you can understand it even more. All right? All right. I'm expecting a little bit more than what I'm seeing here. I understand. Oh, let me apologize. It's a good teacher. I forgot market here. Every other week, every other Saturday, I go to the market. And today was my market week. So I went to the market 6 o'clock this morning, got home minutes to 9 o'clock. And when my faithful Dahlia touched base and I checked, there was no link that was sent out for the class. So I had to go and create a link. So I asked Dahlia to delay for about a half an hour. So the link actually came in about 9:45 when I sent it out. So I apologize for that. It's not that I wasn't ready. Well, you can say I wasn't ready too because I had to go to the market. But you will understand, that I have to, do some stuff. This class come up on us, you and me, at a point where we just have to do what we need to do. But anyhow, with that said, don't worry about it. We will be able to finish the syllabus. I have started writing your exam because yesterday exams reached out to me when I told them that I only started this week. They said, Mr. Shant, I need the exam paper on Monday. And I'm saying to you students, based on what I would have prepared for so far, I have only 2 questions out of the 4 questions. So far, what I have prepared are questions that one question we don't do yet, but I know we're getting there soon. The other question that I put on is what I'm hoping to move into today. And then, of course, you're going to get questions on what I did like last night and what I'm going to be doing this day. So that will be like the 3rd question that I'm going to put on. Now, mark you, the questions that I'm putting on the exam, CCCJ has the right to change anything that I put there. But I'm saying to you, I'm putting a paper in a way that I know you guys can pass the exam. Chances are, it may very well be my paper that comes back. And I'm preparing you for it. And that's what I was saying to Penn. Don't worry about it. Just come a class, turn up, and you will be good. Turn up, and you'll be good. Matter of fact, Penn, you want Candice work same place? Penn gone sleep again. All right. Anyhow, all right. So I'm letting in students as we speak.
No, sir, it's close by.
Oh, okay, cool. Letting in students as we speak. There are 17 of you here. I think I need to begin.
Sir,
Go ahead.
sir,
Yes, Roderick.
I'm at work here. But me,
Oh, Jesus, you work Monday to Friday and then on Saturday? Sure.
and then one of the bad things are, sir, but me I go on.
All
But
right, no
me
problem.
not going to work next week, look, I'm telling them, say, me have to, last week this me work, as we have class on Saturdays now.
All right, no problem.
Mhm.
All right.
Sir,
So
and
go ahead,
sir,
Sean.
and if you can on Monday, follow up with them because well, I'm still not allowed to select the course and area, and I'm not sure if anyone else have that problem.
All right. So yesterday I was unable. All right. So all right. Last thing before we begin. So Sean, you're talking about the overrides. I went to work yesterday morning specifically to sit and complete the overrides for the business calculus and the pre-calculus. Those two courses in particular. Try as I may, Sean, I could not get onto my desktop in the office. And I went to ICT and I complained. And they said, well, change your password. I said, no. Because when I'm at home, I'm able to get on, so I know my password works. And then I went to somebody else's office and I log on the system and my password, it went through. And I went to somebody else's office and I tried and it went through. Went back to my office, tried, never got through. So that's why the overrides wasn't done yesterday. And in
Sir,
addition, go ahead.
question. Will there be a your name on Aaron specifically, or we're going to use the one for Mrs. O?
No, for me.
Oh,
You
okay,
have to
all
look for
right.
me in particular, yeah.
Oh yeah.
Because if you don't look for me particular, that's a very good question. Students, you have to, let me just go to my
So you
area
don't
now.
come up for the year 3 students. You only come up if I select the associate and area, which you've already completed. But when
No,
I
but you have to do the associates because the business calculus is in the associates. So you're not
also
going to see
go
it in the
over
year
that
3.
side to do the registration.
Yeah, man. Yeah, man.
Okay.
EEORION. Sean, you asked a very good question. So let me get onto my area because if you
Sir,
select,
can
this is what
I
I'm
ask
trying
a
to say.
question before you go further, sir?
Go ahead.
I have to select the course, or IT going to start that talk, because I select the courses for here, 3 already, so I have to go in and select business calculus.
Um,
I'm not sure it go.
no, you won't on it because maybe
I
that's why
have
you
the
guys never
same
get the link.
concern. I have the same concern, Roger. Because when we select to go to year 3, it's not the same selection as when we are doing the
No,
associates.
is that different? Is that different catalog? So you have to go over to the associates to select the business calculus. All right. No, I see why the link wasn't sent over, because the only thing that I'm seeing on my profile for this year are what me never know. Oh yeah, are 2 pre-calculus classes and a calculus 1 class. I'm not seeing the business calculus there. So that's why the link never come up, because even though it's on my timetable, I'm seeing it on my timetable, I don't know why it wasn't sent over. All right, so let me just make a telephone call now before I begin. I have to begin now because I know what it is that I want to complete today. Let me just make a quick call before I forget. BUKU. Just make a quick call before. I'm not seeing it on my dashboard. Good morning, sir. How are you? All right. I am in business calculus now for the block scheduling group. What is what? I'm in the class now for the block scheduling students, business calculus. All right. So a very good question was asked just now that I need to verify. I'm wanting to verify for me on Monday. I previously sent all 3 of you the list of names of students. Grateful if those students could be selected and placed on Arion for the courses. Some of the students have already moved over to year 3, and some are just trying to finish off this to move to year 3 in January. I looked at my Arion just now and I'm seeing my other classes, but I'm not seeing this block scheduling this calculus class. So as a result of that, there was no link that was sent out this morning. So I had to go and create a link. So I'm going to ask, please, sir, if you can just work on that first thing Monday morning, because the students also are saying that they need to pay for the course. You know, right. I just said to them today a while ago that we met only once this week, early bird. So I told them that we need to increase the days. So I will confirm with them today which days in the coming next week we are going to a meeting so we can set it. And then we'll put the other times right. So I'll give you that. I'll give it. Go ahead. Yeah, man. It's not. Yeah, man. That's not an issue, because if no link is sent, so Sershan will find ways of creating the class. My only issue is that we need to know, be able to communicate to CCCJ how many students are doing this block scheduling, because I was asked this week, yesterday as a matter of fact, about the exam paper. So I'm about halfway the exam paper already. So on Monday morning, huh? For the exam paper, yeah, I told them that we're doing a block scheduling, and exams told me no, they don't know about it. So I told them, yes, man, stick to business. So exams told me that I must carry the paper in on Monday. So so I'm finishing off this class, and then I will go and finish off the exam paper today, so I can send it off on Monday. But also, what is important is that for CCCJ to know how many students are going to be doing the block scheduling. All right. Big up yourself. All right. Thank you, sir. Cool. All right. So whoever asked that question, thank you very much. It was a very good question. And that's why you can pass the business calculus, because you're smart. All right. Let's go. I must move. If you have any other burning issue, make we pause a little bit before, and then I must move into this. All right. So,
What's sorry, you know something about me and Dahlia issue?
yeah, man, we soon talk about that one day. Don't move in now. We soon talk about you and that one. All right. But I did say it actually. I did say that you're not going to find it in the bachelor's catalog. You have to go into the associate's catalog to find the business calculus. But chances are you may not find it, because I'm not sure if it is added. If any one of you have already selected business calculus this class on Arion?
Yes, sir. I'm under Miss.
So yours is not added.
Sir, I did click Miss Hall Francis at first. That's before I knew about your class.
Oh, okay.
Mhm.
So mine is not added. So you would now need to unclick Mrs. Hall Francis. And if you're doing a course with me, you need to click me. If you're doing a course with Mrs. Hall Francis, that's fine. And if you're in Mrs. Hall Francis class, you can stay here with me today. And if you want to wake up with me on morning time, you can wake up. It's not a problem. But for those of you who are doing the block scheduling, you must select me, because if you select Mrs. Hall Francis, CCCJ will not have a record of you doing the exam in late October or early November. All right. So you have to make sure you select me. So I'm going to sort that out. Dahlia sent me a list.
Sir,
Go ahead, please.
how do I unclick from Miss Hall Francis? It's already added. I registered from the first, I think from the
Don't
first
worry.
week.
Don't worry
And
about
so,
it. I will you have to send me an email.
all
Send me
right.
an email so I can deregister you and re-register you. So it's an easy one too.
Okay.
Big up yourself. Who is this, by the way? Oh,
Kimaya
Kimaya.
Samuel.
Okay, yeah, man.
Yeah.
Okay, Kimaya. Just send me a message, right, Mom?
Third question.
Okay.
Is
Go ahead.
Francis class not a block schedule?
No.
Okay.
So again, finally, before I move into the example I have on screen, if you're in Mrs. Hall Francis class and you just want to come here for a little, makeup, touch up, whatever the situation you want it, I have no problems. You can stay. You're most welcome. This class, however, is created specifically for those students who are doing the block scheduling business calculus, who will do their exam the end of October or the first week in November. Please remember that. And I'm saying the end of October, the first week. I may be speaking out of turn because I don't know when the exam is going to be. Nobody can tell me just yet. But I'm hopeful that's the end of October. Better yet, the first week of November. Let's go. So last night we had an interesting session, and Miss Kenny is not here. I was looking for her earlier. Oh, she reached now. Just wake up, you know. So last night we had a conversation with the Calculus 1 students. Oh, I also invite them if they want. Them can come sit down and see what we're going. And we looked at the indeterminate form. Now, on screen, you're seeing me looking at the indeterminate form 0 over 0. I had previously done 0 over 0 with the Calculus 1 students. And because I was inviting you to their class, I really couldn't reteach what it is that I taught them. So I moved on to something else, which is the indeterminate form, infinity over infinity. So I did that last night. Matter of fact, I did and completed that topic last night. Interestingly though, some students I don't think fully understood it. So I'm gonna teach this one here now, the 0 over 0 form.
Sir, I
And
don't
then
understand it none at all, sir. I not fully or half, I don't understand nothing. Cause through me come all day, the rain catch me, I'm in the traffic. Me come all day, so I miss everything totally.
No problem. So what it is I'm going to do is I'm going to go over the infinity over infinity today in class. But I'm going to do this one now. So I want you undivided. I know you might not be at work and so forth, but I'm going to beg you to give me some close attention so we can get this thing out of the way. Let's go. So it says the indeterminate form 0 over 0. This one says we're calculating the limit as x tends to 3 of x squared minus 5x plus 6 over x minus 3. All right? I'm calculating the limit as x tends to 3. As x tends to 3. All right. They're asking me how many students I have. I don't even know how many students I have. How many students in here now? Is everybody here now doing the block scheduling, or do I have some visitors here?
You have visitors like myself, sir.
I'm a visitor, sir.
All right, so 2 visitors. Anybody else a visitor? All right, so I have 2 visitors plus myself. That's 3. That means I have 15. But Penn just left, or Kenny came back because Penny just left. But oh geez, all right, you know what? We're not gonna respond to him yet. All right, I'll respond to him afterwards. Right. So we're looking at this form. So what we're going to be saying to ourselves is now, the limit as x tends to 3 of x squared minus 5x plus 6. Look at what we're doing. We're using the calculations approach. You remember we spoke about assuming x to be equals to 3. It means that anywhere in the function I see x, I'm going to put 3. It means that anywhere in the function I see x, I'm going to put 3. So look at what is going to happen. I'm going to have 3 squares minus 5 times 3 plus 6 all over 3 minus 3. 3 squares is 9, talk truth, or is it 6?
9, sir.
Good job. 5 times 3 is 15, so that's minus 15 plus 6 over 3 minus 3. 9 minus 15 equals?
-4.
Negative 6.
-6, sorry.
And negative 6 plus 6 equals?
0.
And 3 minus 3 equals?
0.
Good. That's the indeterminate form.
I said
That's
it easy, sir. I did say it on show last night, sir.
This I was showing you something similar to this. This is a different format though. So this is the indeterminate form. So now that you know it's indeterminate, you have to do one of 3 things. You have to do one of 3 things. 1, a factorization. 2, a rationalization. Or 3, a simplification. So it's one of 3 things. So hear me out. May I do the something, but I recognize that I can't get the true limit. Something I block it. something is blocking it, right? Put it this way. If you have senior parents, it is almost guaranteed that they will have to do cataract surgery because it's one of the eye diseases that many people are suffering from. All right. So when you have cataract, it is blocking your vision. You're not seeing well. But when you would have completed your cataract surgery, it means that you're removing the cataract that builds up over the eye. And then you can see. So you're not seeing well because of the cataract. When you remove the cataract, you can see perfectly. And some people, when they remove the cataract, they might have 20/20 vision. They don't need no glasses again. Real talk. It's the same thing right here, so. I am doing the limit of the function. Something is blocking it. The cataract is blocking it. Something blocking it. Now, in order for me to do the cataract surgery, I will have to do either a factorization, a rationalization, or a simplification. I have to do something as simple as one of these things so that I can remove what is causing the problem. And once I remove what is causing the problem, I am going to be good to go. Once I remove what is causing the problem, I will be good to go. And good in such a way that I can now calculate the limit of the function, just like how good in such a way that you don't have to worry about not being able to see properly. Yeah, watch me. Watch what I'm doing. I recognize. Let me pause and tell you a story right here. So the question not done yet. You just a start. You're just starting because you only know recognizing that you have an indeterminate form. Sir, how do I know I have an indeterminate form? When you have 0 over 0. The limit is not 0. The limit is not 0 over 0. All right? The 0 over 0 is telling you that you have something blocking something. You now need to unblock it so that you can go and do the actual calculation. Watch teacher. X squared minus 5x plus 6. I'm now going to be factorizing x squared minus 5x plus 6. I'm looking at the coefficient of x squared. The coefficient of x squared is a number in front of x squared. I'm looking at the number in front of x squared, which is 1. And I'm looking at my constant term, which is 6. My constant term is that term that stands alone. And block scheduling students, very soon, like one of these early mornings this week, I am going to be moving into differentiation, and you'll hear me speak more of constants. And I will say to you that the differential of a constant is equal to 0. I've given you that little piece of the story from now so that when you hear it, it's not new to you. So I'm multiplying the coefficient of x squared by the constant. 1 times positive 6 is positive 6. I'm prime factorizing. My first prime number is 2. So is 2 a factor of 6? It's yes. So 2 into 6 goes how many times again?
3.
Can I use 2 again now?
No.
I move up to?
Excuse me, sir.
Go
3.
right ahead.
Before you go any further, how you got it to?
Who's the first prime number? I'm prime factorizing. So I'm only using prime numbers. So remember, prime numbers are numbers that have exactly 2 factors, itself and 1. And 2, the only even number, which is prime, so I'm starting off with 2. I wouldn't start off with 3, even though 3 is a factor of 6. I'm starting off with the lowest prime number. And then when I can't go anymore with that prime number, I move up to the next prime number. So I didn't move on to 4 because I couldn't do that.
Okay, I
All
get
right?
you.
You
Yeah.
follow what I'm saying?
Yes, sir.
All right, so just remember that. So we're doing the prime factorization, so we're starting off with that. Give me 1 second. All right, students. So yeah, man. So we're using prime factorization. Remember, 4 is not a prime number. 4 is a composite number. All right. So we're using prime numbers in order to do this stuff. But you will see more of these though. Just try catch what it is that I'm doing. If you don't catch it the first one, I guarantee you by the time I reach the second example, you will see it. I promise you. All right, let's go. So 3 now into 6 goes
2 into 6, sir.
huh?
2
No,
into
it's moving.
Yeah, no, but me said the wrong something. Come and said 3 into 6. It's supposed to be 3 into 3. 3 into 3 goes 1 time. So what I'm saying to you is that my prime factors are 2 times 3. So 2 times 3 gives me 6. But 2 plus 3 is equals to positive 5. I don't want positive 5. What do I want?
-5.
I want negative 5. Because what I want is the middle number.
Yes, sir.
That's what I want. Right? So that's what I want. I want the middle number. So when I multiply it, I'm going to get the product. But when I add it, I'm supposed to get the middle number. So it's a middle number that I want. So hear me now trying to find the middle number. Hear me now trying to find the middle number. 2 plus 3 is positive 5. I don't want positive 5. I want a negative 5. Oh, but sir, in order for you to get negative 5, what I would have to do?
Change your signs.
To what?
Negative.
To -2 and -3, don't?
Yes, sir.
All right, so that is 1. So if I say -2 multiplied by -3, I still get positive 6 right there, sir?
No, sir, I multiplied.
Yeah, man. Hold on, man. -2 times -3 equals what?
Yes, sir.
Positive
Positive
6.
6.
Positive 6, right. And then -2 plus -3 equals what?
Negative 5. Oh, from
All right, sorry. Somebody saying something? I'm not hearing.
Alex, mute your mic.
That's all you do now. So you know why not from it then? Basically that you must say. You know why not from it? That's
Sir, mute Alex.
No,
Maybe.
sir.
I just did. I was wondering if it's me I talk to. I just did. Thanks. All right. Right. So Dahlia, you understand what I was saying to you now, that -2 times -3 is positive 6?
Yes, sir, I knew that, but because we were focusing on getting a -5, that's what I was saying.
Oh, okay.
Multiply.
Got you. So when I add -2 to -3, what do I get now?
Negative 5.
-5. All right. Let us see. Out of 1 or 2, which one I want?
2.
I want 2. Very good. 2 is what I want. Why, sir? Why? I'm not seeing it. Very good question. I need 2 because when I multiply both factors, I'm supposed to get 6. But when added, supposed to give me the middle number. That number there. When added, supposed to give me the middle number. Follow me?
Yes, sir.
Very good. What about the rest of you?
Yes, sir.
And remember, you know, would have done this in foundation classes, CXC foundation. I'm trying to remember if we did this in pre-calculus. We can't remember. No, I can't remember. No, we did indices and logarithms.
Right.
Yes, man, of course we did it in a pre-cal.
Sir,
So,
the factor is in your pre-cal.
We did it in pre-cal, man. Remember, in a pre-cal.
So from your girl school, I come up, me never see that kind of maths yet.
Jeez, I'm Roderick Lacey, man. It's a good thing, say.
Factorization is out here.
You remember in a pre-cal, you get something like that? Something like this, 2 to the x, 2 to the 2x plus 2 to the x minus 5 equals 0. And they would have say, let y be equals to 2 to the x. So therefore, y squared going to be equals 2 to the x. Come on, pen. Come on. 2 to the x all squared, which is equals to 2 to the 2x. And then we would have said, no, this is y squared plus y minus 5 equals 0. And then we have to factorize. Nobody remember that?
Yes, sir, I did it.
Yeah, man, we did this in a pre-calculus, man. So you'd have met this topic again in pre-calculus. Yeah, man. All right. So I'm going to keep this right here to say recall. R-E-C-A-L-L, recall pre-calculus. Yeah, man. So we did that topic in pre-calculus. All right. So now, so we're going to find, we're going to find, because I wrote that there, we're going to need a space. So we're going to see if we can finish a factorization here. So now, we're going to finish a factorization here. So we're going to say our factors are -2 and -3. So we're going to have x squared minus 2x minus 3x plus 6. Then I'm going to group. I put in x squared minus 2x in one bracket. I leave out the middle sign every time. Once the middle sign is once the sign in the middle is a negative, I have to flip the number that is right here. So that number now going to become a negative. Whatsoever sign that is right here, so has to be the same sign that is right here. So what is common between x squared and 2x?
Sir, what if it was a plus sign instead of a negative? We still put the plus sign
What if it's a plus sign where?
in the middle, before you put the
No, yeah, man.
3x
Once
in
it's
the
a
bracket.
once it is a plus sign in the middle, you don't need to do nothing.
Or just put the open bracket and start putting the numbers.
Yeah, man. Once a plus sign in the middle, not change nothing.
Mm-hmm.
You see, once you have a negative sign in the middle, the last sign they saw, I forgot flip.
Okay.
Let me show somebody. Somebody look at this, please. What I'm saying to you, once this sign here is a negative sign, this sign has to be flipped. Follow me? I don't think you can say that word. Somebody say yes, no, please.
Yes, sir. Yes, sir.
You have to flip that sign. All right? And why you flip the sign? Watch me now. What is this negative? And incidentally, there's a -1 here. What is that -1 times this -6? -1 times -6 is what?
Positive.
See it here, sir? So the +6 right there, sir?
Change back to the positive.
All right. So that's why we do that. So it's not really magic that we're working. It's just how it's supposed to work out. All right. I'm recognizing that my
Sir.
pen. Go ahead, please.
What you said, once any sign in the middle, you switch it around, you flip it.
Once the sign is negative, you have to go flip it.
Just negative alone?
Only negative alone. Yes, my love.
Okay.
Okay. All right, Katie, no problem. All right. Shaniqua, I will need to think about that one and then get back to you. All right. Shauna, trust me, my computer crashed and I had to go and buy a different device. So normally I'd project you call it now, a Microsoft Word document and just write in the Word document on my tablet and the whole stuff. I have to do it differently now because I still have the tablet, but the computer crashed. Fortunately, one of my business calculus students, my calculus 1 students, of course they are competing students, says to me, sir, take the computer to me, I'll look at it for you. So if that one comes up, I can revert to it. But if not, apologies for this. But as it is just now, as it stands, this is the only device I have really that I can do the session with. I understand, so I apologize from before because I can't do anything better now. All right. So here now, What is common between x squared and -2? Answer me. What is common between x squared and -2?
-1. No, x.
Sorry. No, stop. I asked the question wrong. What is common between x squared and -2x?
X.
Thank you. X. Is when you answer me, Dahlia, I was like, what the heck? So it's going to be x. What is left?
Squared.
Say x.
Oh, yes, x.
And what else?
Nine.
2.
-2. Very good. -2. What is common between 3x and 6?
3.
3.
Very good. What is left?
X minus
X minus 2.
2.
Good. Good job. What is common now between x minus 2? Sorry, what is common between x times x minus 2 minus 3 times x minus 2? What is common?
X minus 2.
X minus.
Very good. And what is left?
X minus 3.
Minus 3.
Very good. So now I
You know, all along you teach me this from foundation, come straight up and I just get it.
Very well. I'm happy you get it now. Very nice. I'm happy you get it now. Why is it like this? Mosquitoes in inviting me. Hey, mosquito, go. Sure. Yeah, man. So I say it go. Now, remember, this piece here was a recall. I don't want to erase it because I want people to remember that, yo, we did do this thing here, So I want to put this as a recall, right? Then I'm going to jump now to the remainder of the question. The question was what again? X squared minus 5x plus 6. So the question, x squared minus 5x plus 6. Over what? Over x minus
3.
X minus 3. Thank you. Over x minus 3. And all of that was going to x is tending to 3. Look at what Sir's doing now. Sir, we're going to say, yo, this is going to be x minus 3 times x minus 2 all over x minus 3. You see how I'm just rewriting this stuff? Because our x squared minus 5x minus 6, plus 6, is the same thing as x minus 3 times x minus 2. So when I rewrite the stuff now, look at what I'm able to do. I'm able to say, yo, come out of your so. Come out of your so. Those two things are the cataract. And them prevent the true limit of the function from coming out. So now I can rewrite my limit to say limit as x tends to 3 of x minus 2. And then from the calculations approach, I'm assuming that x is equal to 3. So I'm going to say, yo, 3 minus 2 is equal to 1. So the limit as x tends to 3 of x squared minus 5x plus 6 all over x minus 3 is going to be equals to 1. That's my answer. Sir, it look like enough. I agree with you. I just minimizing so you can see. It looks like enough, but it really isn't difficult. Allow me now to just use, yeah, it's a whole page, yeah, but you get enough marks for it. I think a question like this carries, for the business calculus students, it may care about anywhere between 5 and 8 marks. For the calculus 1 students, it carry about 5 marks. So the business calculus students get a little bit more marks for it than the calculus 1 students. What will happen right here? So I'm going to walk you through the question again. And I want you to just bear with me. Let me bigify it a little bit so you can see what is happening, and I'll move it accordingly. All right. I don't have, as Shauna was saying, sir, what about the computer where you could use the spotlight? I don't have the computer to spotlight, so I don't have a mouse. so you can see what it is that I'm changing around. So you just have to go work with me right here, so. So here what is happening now. Here what
Excuse
is
me,
happening.
sir.
Go ahead, please.
For the prime factorization, we're going to divide until we reach 1.
Absolutely. Very good. Yes, ma'am.
Okay.
Yes, ma'am. All right. Watch me now. Shauna, I just saw your message pop up, and I'm going to ask you to do that for me. So when I'm talking, you can write down what is step 1, and I want the rest of you to do it. You're given the question. The limit as x tends to 3 of x squared minus 5x plus 6 all over x minus 3. The first thing you're going to do is to assume that x is equal to 3. And in assuming that x is equal to 3, you're going to substitute 3 into the function. When you substitute 3 into the function.
So you're not writing anything now?
No. I want you to just look at the screen. Yes, Papa.
Oh, I was saying that, so that's anywhere with the X.
Sorry, screen too small. I can bring it up a little, please.
Whoa. I did something. Oh, crap. You know, it's from last night. I noticed this, you know. Oh, I have an undo button here. Okay. I keep dragging the under words and it keep moving. Is that better, Roderick? Is it better, class?
Yes, sir.
Yes, sir. It's okay.
Yeah.
Okay. So you're given a function. It says the limit as x tends to 3 of x squared minus 5x plus 6 over x minus 3. And you see that? The limit is moving to 3. So your first thing you're going to do is to assume that x is equal to 3. You're assuming that x is equal to 3. Now, in assuming x is equal to 3, anywhere in the function you see x, you're going to be substituting 3. Anywhere in the function you see x, you are going to be substituting 3. Now, this is it. 3 squares, because I have x squared, minus 5 times 3 plus 6 all over 3 minus 3. For those of you who are not following, I'm right here, so. 3 squares are 9. Negative 5 times 3 is negative 15. And I write back my positive 6 over 3 minus 3. We all know that 3 minus 3 is equal to 0. Now, 9 minus 15 is a negative 6. When I'm adding and the signs are different, I subtract the smaller number from the bigger number and put back the sign of the bigger number. So it's going to be negative 6. I'm going to add negative 6 to 6. I'm going to get 0.
You're writing?
No, I'm not. It's already on the screen. So 0 over 0. Can you see that 0 over 0 here? Thanks, Shauna. Anybody else can see it? It's a Shauna don't see it, you know.
Yes, sir. Seeing it.
Okay, good, thanks. Students, I understand that
I
today is
like
Saturday.
when you talk and you're not pointers.
But I am pointing. Look and tell me if you see 2 asterisks on something. Or maybe a screen freeze.
Alright.
Yeah, man. Yeah, man. So just look at the asterisk. So as I said before, I'm not using a computer. Let me see. I wonder if no, but the whiteboard don't give me. But Zoom normally give me, hold on. Zoom normally give me. Let me go to the reaction and see if. Yeah, I'm not seeing. Oh, let me go to apps and see if. All right. The reason I'm looking for it because last night in class another student asked for it, but I know normally all right. It's all right. Any questions so far? Any questions so far? Students, should talk to me now, please.
No, sir.
Sure, I'm following.
Yeah, but you have to.
Sure, me follow.
I'm all the way up until there is the indeterminate form. Just waiting for you to move on.
Okay, no problem. Yeah, I'm not seeing. Yeah, I'm not seeing the highlights on it. All right, so let's continue now then. So now I would recognize that it is indeterminate. What does indeterminate mean? And I want you to listen to me now, because I don't nobody go to Mrs. All Francis and go say, oh, but that's what Mr. Shan says. Because I'll just play back the recording. If when you work out the limit of your function and you get 0, that means that the answer is B. However, when you do your calculation of your rational functions here, and we get 0 over 0, it is 0 over 0. 0 over 0 means something different in mathematics than just write it as 0 by itself. 0 by itself has a different meaning, a far different meaning than 0 over 0. All right? 0 over 0 says it is indeterminate. I must do one of 3 things. I must do a factorization, a rationalization, or a simplification. A factorization, a rationalization, or a simplification. One of 3 things in order to do it. Remember, sir, give you the story about the cataract? Not seeing so well? You remove the cataract, boom, 20/20 vision. All right? So, what I would have to do, I'm looking at my function, my functions given, x squared minus 5x plus 6 and x minus 3. And I'm asking myself, which of the two looks more complicated? What is your answer? If I ask you which of the two looks more complicated, which one would you say?
Sir, which of the two between the x minus 2 and the x minus 3?
No, which of the two? The x squared plus 5x plus 6 or the x minus 3? Which one is simpler? Which one is in the simpler form?
X minus 3.
X minus 3, yeah, you're correct. So x minus 3 is simpler. So I can't see how I can work on x minus 3 any further because it looks like it's in the simplified form. However, I can work out, I can try and work something in the first part. Because the first part looked like it's something that I can work out. So I'm going to be factorizing my x squared minus 5x plus 6. I'm prime factorizing. I'm multiplying the coefficient of x squared by the constant. I am multiplying the coefficient of x squared by the constant. It is going to be 1 multiplied by 6. 1 multiplied by 6 is 6. And I need two numbers. When multiplied together will give me 6, but when added will give me a -5. It simply means that because my prime factors of 6 are 2 and 3, it simply means that those two prime factors will have to be negative. Why, sir? So that when I'm multiplying -2 with -3, or by -3, I am going to have a +6. However, when I add -2 to -3, I will arrive at -5, which is what my middle term is. So I need to be able to fill both conditions, the product and the sum. So I know what my factors are. My factors are now -2 and -3. I am going to break up that -5 into -2 and -3. So I'm going to write now. Watch me. I'm writing now. I'm writing. Come on. So let's just look right here. X squared minus 2x minus 3x. Oh, okay, sir. So when I add the -2x to the -3x, we get -5x. Yes, yes. And then it's going to be +6. I'm breaking up those into those two terms. I'm breaking up those into those two terms. Are you following me so far?
Terminal, so we are right.
Should I say it again that I'm not writing?
Sir, you did say I writing now, but all I did was the blue, what's that, an asterisk?
I said that I was writing?
Yes, sir,
When?
a while ago.
When me say a while ago?
Before that, you say I'm writing now, and then we see the blue asterisk,
Yes.
and then you're going to what you were saying. I think it's because of the board which you understand. So, I guess when he said that, because he's revising now, I guess when he said that he's writing, just probably look to see if you see the asterisk and we'll take it.
And that's what I mean. That's what I mean. I'm writing now, so to see the asterisk, yeah, because I've already written it on the board. Everything is on the board, guys. I'm only just going through the question again. So just look for the asterisks. I have several asterisks there. I'm just trying to highlight some stuff because I don't have the cursor to do the stuff. I'm waiting on you to let me know that you're with me, because I don't want to leave anybody behind.
Yeah.
Mm?
Yes, sir, with you.
Okay. Okay, so let's go. So I'm not writing, but just look at what I have there. The next line says group. So what I'm doing is grouping the first two terms, the last two terms, but the sign that falls in the middle of the first two terms and the last two terms, I'm going to leave out. I'm leaving out the middle term. And then I'm going to have x squared minus 2x in the first bracket. Leave out my negative sign. Just leave it out. And then I'm going to put the other numbers there now. 3x plus 6 in another bracket. Are you following that step?
Yes, sir.
Good job. And then I'm asking the question. I'm astericking here. Right here, so I reach. What is common? I'm asking a question from this side to arrive at the one down here. What is common between x squared and negative 2x?
Is that for everyone, sir, or just her?
For everyone.
X, sir.
Thank you. Students. Thanks, Shauna. Students, please, my big one. I know it's a Saturday. I know you're multitasking. I know some of you gone to work, but it feels a little strenuous on me trying to do the revision of the question that I just did. The revision is even taking longer than the question because you guys are not thinking. If you want me to just talk it through, I can talk it through without asking you the question. Go ahead.
I think it's because you're just a talk and you're not pointing. It's hard to follow.
All right. You know what? So let us move on to another question then. So you can see me writing. Because students, it is what it is that we have. I don't have another device. And all right, let's go. 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 Let's go.
Sir?
Yes, please.
Yeah, so one of the things that I'm observing as it relates to now, because on my screen it says that I'm following Mark Shand. And so I have to keep going and well, I always have to be checking. At the top it may say following is paused. So what is this now? If I'm not following you, I can't see when you're moving the cursor on the screen. Yeah, so that may be one of the issues.
Yeah, but I'm also saying that it is.
I hear you talking, so I know where you are, but the screen keeps asking me to follow you. So if I don't do that, I don't know when you move the screen up or when you move it down.
Got you. Yeah, but all right, let's just see how we can overcome that.
No problem.
Let me see how we can overcome this. All right, guys. I'm not going to continue the revision because you're not following what it is that I'm doing. I think you're following better when I'm writing. So I'll do the question and not revise it. All right. I'm going to look at a second question. I'm going to call that number 2. All right, let me put that in green. Number 2. And let me see the limit as x tends to -5 of x plus 5 all over x squared plus 8x plus 15. X squared plus 8x plus 15. What's the first thing I'm supposed to do here?
Substitute.
Yeah, substitute x with 5.
Thank you very
So
much.
everywhere x is, it's now -5.
Very good. And I really hope that the rest of you are following. -5 plus 5 is going to be equal to 0. Let's just check if the bottom part is 0. -5 squares is positive 25. And -5 times 8 is 40. 25 minus 40 is -15. -15 plus 15 equals?
0.
Equals 0.
All right, and guys, this marks the first part of the question.
And what is this part known as?
Indeterminate, right.
So it's indeterminate. Now we know it says indeterminate, something will cause something from not coming out. So what we're going to be doing now is to look at it to say, you know what? I'm going to factorize x squared plus 8x plus 15. I'm multiplying the coefficient of x squared by the constant. The coefficient of x squared is a number in front of x squared. What number is in front of x squared, sir? Is a 1. X is not 1. The coefficient of x squared is 1. 1 times 15 is? 1 times 50 is 15. So I'm going to be prime factorizing 15. So those of you who ask me about prime factorization, here it goes again. I'm prime factorizing 15. Do I start with 2?
3.
Very good.
No, you start with 1.
3 into 15?
5.
Not 1, but 3. 1 is not a prime number. 3 into 15 goes 5.
3, sorry.
And then, do I go with 3 again?
5, sir.
5. Good job. Thanks, Sean. And 5 into 5 goes?
1.
1 time. So here, I have my two numbers, 5 and 3. Let me look at the middle number now and see what I want. What do I want? I want a positive 8 or I want a negative 8?
Positive.
Positive.
Good. So what am I going to use as my factors? What am I using as my factors?
5.
And?
3.
3
And
and
3.
5.
3 and 5. So my factors are 3 and 5. So look at what I'm doing. I'm x squared plus 3x plus 5x. You see that I break out my 8x into 3x and 5x now?
Yeah.
Good job. Then I'm going to group x squared plus 3x in one bracket. If only this pen would continue writing. Give it a minute. X squared plus 3x in one bracket. Leave out the middle sign every single time. Watch this now. It's because that middle sign is a positive sign. I'm not flipping anything and writing back the numbers as they are. The only time I'm going to flip is when I have a middle sign. I have a negative sign in the middle. That's the only time I'll flip, when I have a negative sign in the middle. Outside of that, not flipping. What is common between x squared and 3x?
X.
Good job. What is left?
X and 3.
3 and 5.
3 what? No, don't tell me this x and 3. X plus 3. What is common between 5x and 15?
5.
5.
Good job. What is left?
X
Plus 5.
plus 5. No, 3. X plus 3.
Good job. What is common now between x times x plus 3 and 5 times x plus 3?
X plus 3.
Good job.
X plus.
And what is left is going to be x plus 5. So now I have factorized my function. So I can now rewrite it, limit as x tends to negative 5. I can now rewrite it, the limit as x tends to negative 5 of x plus 5 over x plus 3 times x plus 5. Because I've broken up my x squared plus 8x plus 15 into those two factors. Look at what is going to happen now. This is what was causing the problem. So I'm taking it out. So I'm going to be left with the limit as x tends to negative 5 of 1 over x plus 3. Follow me?
Yes, sir.
Good job.
And the
Now
calculation.
look at what is going to happen. Now I'm going to substitute the values. Here it goes.
Well, answer.
Mm-hmm.
So the limit you have x plus 5. over x plus 3, x plus 5. Yeah, come let me blink too fast. All right, sir. Go on, let me see what you do.
X plus 5 into x plus 5 goes one time. X plus 5 into x plus 5 goes one time. So I have a 1 remaining in there in the numerator, which is this one right here. So
Okay.
I know that's what you're missing.
Because me say me look like me blink too fast. Because I wonder how you reach down at the bottom part.
Cancellation, give it a 1.
Right.
Okay.
And then now, when I do that substitution, -5 plus 3 is -2.
-2.
So I'm going to get -1/2. So I can conclude that the limit of the function and that's your answer. How you feel?
Not bad, sir. I'm going. I just did the factorization part. After I reach right there, so group everything and then do the factorization. Yeah. But coming down to the indeterminate form and then starting back at the limit, x approaching -5. Yeah. I also need to get that factorization part in, that group setting right here. But for the most part, yeah, I'm following you.
What about the rest of you?
Yes, sir. Following.
All right. I'm going to give you something to do for me. That's my only true way of knowing that you are truly following. All right. On the mark, get set, go. All right. I'm going to step away for maybe about 10 minutes. But you should be able to work on those within those 10 minutes. And then that will be the end of the 0/0. And then I'm going to review what it is that we did last night. So these two are the last two questions I will give you on the 0/0 indeterminate form. Let me see if I can just minimize somewhat so you can see the whole question. Is that okay?
Yes, sir.
All right. I'm stepping away for a few. Give me about 10 minutes, please. I need to go and do something. All right. I'll be back. Are we finished?
Not yet, sir.
Okay, no problem. Not rushing you. Just want to make sure that you are engaged in the working process. Hmm. Let me know when you finish here, guys. I don't want to interrupt you because I want to make sure that you're understanding. Take your time and do the question, and then we'll come through for the solution together. Okay, all right. I'm seeing that response. No, man. Only look like we're not gonna market. I'm not gonna market gun shop, man. Always stay. I've been responding to students in the chat, and they have gotten the correct answers. Talk to me, students. 2 more minutes. 2 dege minutes left. Students, I don't understand. You know how to do the work.
Ready for you, sir. Ready for you. Ready for you, sir.
All right, so you ready, and I marked 2 already in the chat. Where are the others? The others don't finish yet.
They're ready.
You ready? Roderick, are you there, Roderick?
I'm there, but me still I do it, sir. You know me slower than everybody else, so me have to take my little time.
Listen to me, brother. 1 minute. 1 minute I'm giving you, Roderick. All right.
All right, sir. Then you can start work. Let me see what I want. Let me fall short. Four times. I don't know. All right, sir.
Ready or not, here I come. You can't hide. Students, let me tell you what I'm figuring is happening today. Where is this pen, Jesus? Okay. People are not working. Full stop. And that makes me sad. All right, let me go to the question. Let me see if I can.
What makes you sad, sir?
There are some students in the class that are really not doing anything at all. And I know there are others who have done. I have responded to a few messages in the chat.
But me not see nothing in the chat, so that's why I'm gonna post my one.
No, man, they said it to me privately.
Oh, all right. Well, yeah.
And I responded to them. All right, let me do this one here. So so I'm gonna say, I'm gonna assume x to be equals to -1. So 2 times -1 square plus 5 times -1 plus 3 all over -1 plus 1. We can see that the denominator is already 0, don't?
Yes, sir.
All right, and -1 squares is +1. And +1 times 2 is, okay, Shan, I see that. No, man, you did tell me that already, Shan, so I know about that for you. I'm happy to know that you're listening in. 2 times -1 is, sorry, rubbishness. -1 squares is +1. +1 times 2 is 2. But -1 times 5 is a -5. So I'm going to have 2 minus 5. 2 minus 5 is -3, and -3 plus 3. This one is also 0. Can you see that?
Yes, sir.
Sir.
So that's indeterminate. So already, me not go waste no time. I know that this is supposed to factorize 2x squared plus 5x plus 3. I'm multiplying the coefficient of x squared by the constant. 2 times 3 is 6. And prime factorizing 6. 2 into 6 goes 3 times. 3 into 6 goes 1 time. 3 into 3. Go ahead.
What did you multiply to get the 6? The 2 and the 3?
Yes, ma'am. I'm multiplying the coefficient of x squared by the constant. You see that?
Yeah.
Every single time. No, the other questions that I did, the coefficient of x squared was 1. So it would appear that is only the constant term that I used. But I was very deliberate when I'm doing the other ones to put the 1 in front of the x squared in a different color. Can anybody remember that?
Yes, sir.
See it here? That's one example. And the other example is, see it here again? 2 examples, right? So I'm always very mindful when I'm teaching this topic that I don't want students in the first part to think, oh, sir, the 15 here so we get is because the constant is 15. No, it is the multiplication of the coefficient of x squared by the constant term. Always. So I need 2 numbers. When multiplied together will give me 6, but when added will give me 5, +5. What 2 numbers we're talking about?
Sorry, that's not my challenge. My goodness.
And Shauna, I would agree with you, because I remember you having a challenge with this in the pre-calculus as well. And I know, my love, that the factorization is not the easiest of them all to catch. You caught it, however, you know, Shauna, you did catch it, you know. But if you don't use it consistently, you're going to lose it. So all I know you have to do, Shauna, is just to revise it. And I'm positive once you do that revision on that today, you'll catch it.
So the concept of it, I get it, but when it's to find the 2 numbers, that's where I fall short.
Okay, so guess what,
So
now, Shauna?
I can't identify. which number, I don't know how to apply it. So that's where my challenge is.
Okay, and thanks for that. So you're multiplying the coefficient of x squared by the constant. You're multiplying the coefficient of x squared by the constant. The coefficient of x squared is the number in front of x squared. And in this case, it's 2. You're multiplying 2 by 3, the constant, you're going to get 6. You need two numbers. When multiplied together will give you 6, but when added will give you the middle number, which is 5, and not any all 5 neither. You want a positive 5. All right? So, when you prime factorize the 6 now, you recognize that the prime factors of 6 are 2 and 3. When you multiply together 2 to 3, you're going to get 6. But when you add 2 and 3, you're going to get a 5. So you would have found your factors. You would have found your prime factors. And then, what we're going to do from there is, you're just going to make the substitution. You're breaking up now. You're breaking up now the prime factors into 2x and 3x to give it a 5x. Look at that and tell me that you agree with me. Shauna, my love, is is more. Okay, great. All right. So, so what I'm going to do now is to continue with the question. And how am I going to continue? I'm going to be saying, I'm going to be saying, I'm just going to go ahead and break it up. Watch me. I'm going to say factors are 2 and 3. 2x squared plus 2x plus 3x plus 3. Then, sir, does it matter which one we use first? No, it doesn't. I can put in 2 first, 2x first, or I can write 3x first. It really doesn't matter which one of them I put first. It really doesn't matter. All right? So, look at what I'm going to do next. I'm going to group. So I'm going to have 2x squared plus 2x in one bracket. Remember, we're leaving out the middle sign every single time. We're leaving out the middle sign every single time. And then, what I'm going to be doing thereafter is to say, what is common between 2x squared and 2x? What is common between 2x squared and 2x?
X.
2x. 2x.
2x, very good. 2x is common. So you can take out 2x all at once. What is left?
X.
Good job. And? Say plus 1.
1.
Yes, plus 1. Oh, come on, pen. Jeez, man. Sure. What is common between 3x and 3?
3.
And what is left?
X plus
X
1.
plus 1.
Good job. So now I have 2x plus 3 times x plus 1. So what I'm doing here is to say, over x plus 1. What I'm saying now is that the limit as x tends to negative 1 of 2x plus 3 times x plus 1, come on, pen, x plus 1, all over x plus 1. And we can all see now what was preventing the true limit from coming out, them two here. So you take out those. So what you're going to be having left now is the limit as x tends to negative 1 of 2x 2x plus 3. Anywhere in the function I see x, I put negative 1. So it's 2 times negative 1 plus 3. 2 times negative 1 is negative 2 plus 3 is equals to 1. So 1 is going to be your answer. Quite a number of you got the 1 before because you were having conversations with me in the chat. Let me just that. You were having conversations with me in the chat. Let me pause right there. Any questions?
Why you didn't do this for the first one?
Do what?
Where you start at limit. Alright, the one mode where the 2x plus 3, then the x plus 1 over x plus 1. I realized you didn't do that for the first one when you just start class.
I did.
You did? Good. Alright, sir.
No, man, that's fine, man. I don't feel any way about it. Look at the one in green and tell me if you see it. The x plus 5 over the x plus 5, you see that? Look at where I use a different color to do a cancellation in the green writing. You see the x plus 5 cancelling out the x plus 5?
Yes, sir, I saw that one.
All right, good. Hold on again now. Look at this one here in the black now. You see I cancel with green, the x plus 3, the x minus 3 and the x minus 3? Talk to me now.
Yes.
Yeah, man, good. So that's what we'll always do, right? So guess what? One of the things that I'm going to thank you for is for paying attention, because you were looking and you weren't seeing something that struck a chord, and that's why you asked the question. So whenever you're looking at it again when sir teaching and you're not seeing something, just stop me and say, sir, why never do this the last time? And make sure just point it out here. So I appreciate your comment just now. And the rest of you, talk to me. Me know what happened, you know. Sir Lucky, me gonna strip my chicken foot for put on my stove for cook my chicken foot soup later. Guys, remember, this is only for a couple of weeks. This is just week 1 for us. Ouch. All right, let's go. Numero dos. Number 2. So we're going to be looking at the function, and this one says the limit as etc. Okay, so we're going to assume x to be equal to -3. So we're going to put -3 into the function. Wherever we see x, we're going to put -3 plus 7 times -3 plus 12 all over -3 plus +3. 3 3s are 9. 3 9s are 27. 3 7s 21 plus 12 all over -3 plus 3. We can see clearly that the denominator goes directly to 0. And for the numerator, 9 minus 21 is -12, and -12 plus 12 is 0. So we can conclude and say, make a statement indeterminate. We can make our statement to say that it's indeterminate. Remember, you don't get a mark for saying this, but you have to show it. Where the marks come in now is you recognizing that you have to do a small step. So we're going to factorize. More than likely, your small step is going to be a factorization. I'm multiplying the coefficient of x squared by the constant. I'm multiplying the coefficient of x squared by the constant. The coefficient of x squared is the number in front of x squared. I'm multiplying the coefficient of x squared by the constant. And when I do, I'm going to find my numbers to prime factorize. So 1 times 12 is 12. I need two numbers. When multiplied together will give me 12, but when added will give me 7. Added will give me the middle number. First prime number is 2. So 2 into 12 goes 6 times. I can go 2 again.
Again.
2 into 6 goes 3 times. I can't use 2, but I have to use
3.
Good job. And 3 into 3 goes 1. Now, once I reach the 1, and know so I finished my factorization. Somebody asked earlier, and I said yes. Once I reach a 1, I know that I finished my factorization. And then no, I need two numbers. All the questions we've done so far, when we prime factorize, we got two numbers. This is the first
Sorry,
one.
hold on. Let me ask a question. Why you didn't use the 3 before the 3 down here?
Which 3
Where you're
talking?
factorizing? Or when you, I don't know, you can't say what you call, when you break it down. So the 2 into 12 goes 3 times, but I use the 3.
No, you have to start. You start with 3 first?
No, I start with 2.
And you said 2 into 12 goes 6 times?
Mm-hmm.
And then when you say 3 into 6 now goes 2 times?
Mm-hmm.
No, you have to use the 2 next. So we're going to use it in order. We're going to use it in sequence. You're not wrong, but we're going to use it in sequence. Don't worry about it. This is the time to make the mistake, Shauna. So you're going to use it, use it in sequence here, and then you can see better what will happen. Stop! What's your... Jeez, I'm father. You know, you have money. Sorry, I'm somewhere and I see where somebody meant writing something. Go ahead.
Is it that the number that you start with, you have to continue using that number until you can no longer go into?
Very good. That's how we do the prime factorization. Yes, please. And it's only prime numbers we're using. That's very important. Only prime numbers. So you couldn't start with 6 and say 6 into 12 goes 2 times, because that's wrong. Because 6 is not a prime number. So it's only prime numbers you're using. Only prime numbers are using. I'm waiting for other comments because I know you were asking. Are you with me with this?
Talking on mute. So we're adding the 2 2s and the 3s, sir, to get a 7.
All right.
Is it 4 and 3? Are we?
It's 4 and 3. You're going to multiply the 2s. 2 times 2.
Very good. Thank you for correcting Dahlia for me. SB Shan. So Dahlia, you're not adding.
Do it, sir, and get it.
No, you will get the answer, based on what you just said a while ago. You don't got the same answer, but you're not adding the 2 and the 2. You're multiplying the 2 by 2 to give 4. You see them two there? Them two there smart, because when I add the 2 2s together, I get the same number as if I multiply them.
But it's only 2 values you're supposed to have.
It's only 2 values, right? I need only 2 numbers. But remember though, you're not adding those, because when we move on to other something, somebody may think that they're adding the 3 plus the 2 to give 5, and then 5 times 2 is 10.
Yes,
no.
Sir.
Shanique, you're saying?
No, sir, we're just saying, yeah, we should multiply, not add.
You should multiply, guys, and not add. And again, I'm going to use this as a teachable moment. Shanique was in the class to say, no, it's a multiplication. But students, you have to talk up, because in some of your minds, you may think that it was an addition that Sir did. But no, it would have been a multiplication. So you have to be very careful. So I'm multiplying these 2 to give me 4. I'm multiplying it to give me 4. And then 4 times 3 is 12, and 4 plus 3 is 7. So my factors are
Where did that again?
I'm multiplying the 2's. 2 times 2 is 4. So what I'm now saying is that I'm going to have 4 times 3 is equal to 12, but 4 plus 3 is equal to 7, which fits the conditions, the condition that I need. I only need 2 numbers, you know. I only need 2 numbers. So I have 3 prime factors right here. 2 times 2 times 3. So I have to manipulate those prime factors in order to come up with only 2. Follow me?
No, sir, I'm kind of confused because 4 not in the table right here. So.
Right. So I'm combining the 2 and the 2. But how do I do the combination? It's multiplication. Pen, what is 2 times 2?
4.
So come the 4 come in now. Because we couldn't use 4 in the first place because 4 is not a prime number. 4 is a composite number. But I don't want 3 numbers. I want only 2. So I have to do a combination. All the other examples I did, when we prime factorize, we only got 2 numbers. See? 3 and 5. 2 and 3. 2 and 3 again. Yeah. So those are there. So you have to get 2 numbers. So I'm combining pen any 2 numbers in order to get to reduce it from 3 numbers to 2 numbers. Tell me that you see it, no, my love.
All
right, cool. If I lose it anytime, pen, just stop me, please, and anybody else, please. So the factors are 4 and 3. No. So I'm going to say, breaking it up now, I'm going to say x squared plus 4x plus 3x plus 12. I'm going to group x squared plus 4x in one bracket. Leave out my middle sign every time. 3x plus 12 in another bracket. Once it's a plus sign, I don't have to do anything else. If it's a negative sign, I have to flip the last sign. I have to flip the last sign. What is common between x squared and 4x?
X.
X.
Good job. What is left?
X.
X plus 4.
Plus 4
Excelente. Excelente. Excelente.
plus 3.
Uh-huh.
So you have
X minus X plus 4. No.
Excelente. What is common now there?
the x plus 4.
Good job. And what is left?
X
plus 3.
Plus 3.
Excellent. Excellent. So now I'm going to rewrite my limit. I'm going to rewrite my limit as the limit as x tends to negative 3 of x plus 4, x plus 3, all over x plus 3. I have seen, oh, come on, pen. I have seen what is causing the problem, those x minus x plus 3. So now I'm going to be left with only x plus 4. And when I put my negative 3 in that value, come on, what is wrong with this pen? I don't know. I need to Google it and find out why. It's not going too good. 4. And it will give my answer to be 1.
Wait there, sir. Oh, you get the x plus 3 underneath the bottom here, sir. I'm not sure if I missed something.
See it right here, sir?
Wait, hold on. Follow, pause. Which part? Oh. All right.
Those are the 2 questions I gave you for homework. I mean, for classwork a while ago.
So you know which one you can get, sir?
The factorization.
No, man, they catch the factorization part. I part where you ask what is left. Like after the grouping part,
Mm-hmm.
we group the x squared plus 4.
Mm-hmm.
We don't know how to figure out what is left, sir. What is common and what is left.
Okay, so you have x squared plus 4, Roderick. And I ask you what is common between x squared and 4x. And your answer is going to be x. Because x can go into them both. And then I'm asking you what is left. What is left meaning now, what do I multiply by x to give me back x squared? And your answer will have to be x. And what is left will mean what it is that I multiply by x to give me 4x. And the answer is going to be 4. So that's why I have the 4 right there.
Sir, I noticed that most of the answers that you get is 1. Is there a reason?
sir.
Is it that we're supposed to get 1 for all? Well, I see there's a half, but we can get any.
You can get any number, my dear.
Okay.
You can get any number. So happen that when I make up these questions that I'm giving are the questions that I made up. It's not questions that I take from a book. So it will happen. Yes, Papa.
Based on the question that the person just asked, right?
Mm-hmm.
And wouldn't the answer be determined by what the limit is as x approach whatever? So the limit says x as x approaches -3, right?
Mm-hmm.
And when we look at how x is approaching -3, whether it's from the left or from the right, wouldn't that determine what the answer would be within a certain scope or range?
No.
No.
Not necessarily. Hold on 1 minute.
Interesting.
Me, I explain the bab, you know, you depend on that. But that is down here, so wow.
All right. So sorry, that was me telling the person beside me, him need to take out the people them 3. All right, look at this now. So you sorry. You recognize now, who was it? Yes, Romain. There's no range of where the values can go. It can go whole number, it can go fraction, it can go negative number, it can go anywhere, and it has no dependence on the limit of the function. You can put in a small limit and get a big answer. You can put in a big limit and get a small answer. It's not dependent. And Shauna, coming back to you, yes, it not have to be 1. It so happened that the questions where teacher make up out time head, it just work out to be 1. All right. So now, okay, good job. I saw both of your comments, Romain and Shauna. Yes, please, SB.
And based on my collection, I'm not sure if I'm correct, but for the common the grouping, both things should always be the same, right?
Oh, absolutely. And that's how it is that I'm in a factor. So you notice how I ask my question? When you say x minus 4, when you say x times x plus 4, sorry, plus 3 times x plus 4, I ask you what is now common to x times x plus 4 plus 3 times x plus 4. I notice what I always do? I always write the one that is common first, the x plus 4, because that's what we're taking out. And then I say to you, what is left? Now watch me. I'm going to mark up something here. Hopefully I can take it out. Watch me. I'm going to put it in red. When I remove this x plus 4, what do I have left?
The x plus.
I have the x left, don't?
Right.
And that x is this x. When I take out this x plus 4, what do I have left?
+3.
And see the plus 3 here? Says what is left, that is when it give me my other product. I take out what is common, and what is left is going to give my product. Make sense?
Yes, sir.
Mm-hmm. All right. That was the indeterminate form, 0 over 0. I'm going to now refresh, recap, and then we end in about a half an hour. I know it's been a morning into afternoon. Let me, before I move into what we did last night, I deliberately use the same thread that I used last night that I'm going to be going through now. Hear me out in Jesus' name. We're not going to follow me when I do here because I'm not rewriting anything here, so you're not going to follow me in Jesus' name. Do I have that mouse? No, but the mouse not going to work. So what are you talking about, mouse? You're using a tablet, sir. It's not going to work. I'm just trying to find out what I could use. No, it's not gonna work. No, it's not gonna work. All right, yeah. let me just give you a little breather before I go into the revision from last class work, last night stuff. This is some of you students. Is one of the things that I pride myself, and I think I was born to be a teacher. When I was much younger, I wanted to be a doctor and God has a sense of humor. Me I tell God, say, me a return doctor. Come, me want to go and say, call in Dr. Shand, please come to the operating theater. Me say, what? Me say, yeah, man, I mean that. But as early as third form, I remember, them times your mother a figurine when they cut a rooster and when they break it, I want chalk in there. Anybody know them something there? Or too young?
Yes, sir.
Jesus and Father. So what me always do? Me always I break them, and if I break them, I get beaten, but I don't care. The beating must wear off. I me save the pieces them because me I go right on the wall. Right? I'm going to go in the back of the house. I'm a pick stick. And I beat the tree them. I said, learn. And every tree I beat them till all the tree them bend. And I beat them. And everything my teacher teach me in a school, I that me go in the back of the yard and I teach the wall them. And I said to my, and my family members would just sit down and watch, and sometimes I turn on and watch them, or watch me, and then I am in my element and I must do my own stuff. And then, I just decided that I'm gonna apply, try and get some better A-level grades to get into med school, and that just never happened. And I thought to myself, I'm gonna teach for 1 year. And I won't tell you how long I'm teaching because I'm sure
As
I'm
you're
teaching
old, you
before.
don't want to look
Go away
old,
from
sir.
here. Go away from here. Go right away. I expected Roderick to say something like that, not you. But yeah, man, and to be honest with you, if I were to do this all over again, I will become a teacher one more time. I just like working with students. It gives me the pleasure in just working and just seeing somebody fulfilling their true potential. Me say when you can see me a road and don't call to me, it's not a problem. It's not a problem. I remember a family member was sick some time ago. Ouch. And I went to Megamart to fill a prescription. And one of my students over there is a pharmacist. I mean, sit down, I feel proud, Couldn't tell me, couldn't talk to me. Me want to get the medication for run home for go give my family. And then me see the student run as big pharmacists are look on the stuff and me just feel nice. Me say, yeah, man. And him did it, and every minute him a look at me and go like him no know who maybe I'm not him pay him no man. Because me do my part already. I said to my students, when you see me on road afterwards, if you don't want to call to me, phone no loss. I have done my part already and I'm moving on to somebody else. Farmer say, fully no. You hear the little face boy come on the window. Excuse me, sir. Your face looks familiar. Do I know you? And I look at him. I say, boy, I taught you chemistry and mathematics. So you should know me. Oh, yes, Mr. Shand. And I said, look at you. And then somebody said to me, then you did teach him or him did teach you? I said, him turned around. I said, no, man, he was my teacher in college. I said, learn that. So already turned pharmacist and medical doctor and lawyer and pilot. I was your teacher. So it gives me pleasure in working with students. Now, what I don't like, this morning before I went to the market, I looked at my phone and a student whose grades were posted, the grades of the class were posted yesterday. I submitted those grades yesterday and they're posted. And one student sent me a lovely email this morning to say how much I am unprofessional and my teaching style is this and questioning that. And I'm going to report you. Of course, you know, your teacher face they don't. And I said, go right ahead. I am well within my rights. Nobody can say I penalize and jeopardize students' well-being. But you know, students, always remember you can't be wrong and strong. The student missed a piece of work. I can safely say no, the student missed a piece of work. And I simply asked the student a question yesterday. Send me something. I can mark it and I can put the grades in. And there are students in this class right now who would benefit from my giving a makeup mid-semester. Can anybody, has anybody received that blessing from me in terms of giving a makeup mid-semester?
Yes, sir.
Okay. All right. So this is not anything strange that I'm saying. And I was planning on giving the student a makeup because the student didn't submit. I received all the things from the other students. I found them and I just didn't receive this one. And I say, you know what? No, man, I'm going to give the student a makeup. But you go write me and tell me, say, me, I'm professional. And among other things, I say, me not give you no opportunity. I go over the course. Let me ask a question. Should I give the opportunity or should the student go over the course?
Go ahead.
Let them do it over back. Sir, knowing you're not an unreasonable person, and if that person really did that poorly, it's the onus is on them because they give chance upon chance. Me know Mr. Shan, he miserable, you know,
Yes, ma'am. Straight up. Me not going to deny that, Dahlia. Me miserable, ma'am, come on to my work.
Sir, it's behind you 100%. And if you show
Yeah.
and say, sir, me need help, it will work you through it. So if that person really failed, the onus is on them. So trust and believe.
All right. So we not say nothing more upon that one day because we just want to find out from my students, you know. Because, you know, it kind of rough, but students, you know, sometimes, you know, and everything will catch our mouth if we say it. How can you say this to somebody who is trying to facilitate you and then, anyhow, we know we can pass this course. Let's go. So, students, I'm going to see how best I can use. It's just a pity I can't find. Let me see right here. So, Azure.
Talking about grades, they finished the FCM
I have them right here, so beside me. And as soon as I'm finished with you, the coursework pieces are done. The coursework piece is done. All I need to do now is just to finish off these, and that's what I'm doing. I'll be doing. I can guarantee you, I'm on recording. I can guarantee you that at some time on Monday, we'll finish that one today. Yeah, at some time on Monday, though I can't tell you again the Monday morning, but sometime on Monday, I will submit those grades. I promise you, man.
So you need to worry before you make anxiety kick me over coming.
No anxiety not kick you over, man. You're good, man.
Sir, you know, sir, the other day I did an exam and I received the grades like 1 week after.
Oh, that's so nice.
I was saying to myself as a lazy lecturer, them lazy.
Yeah, that's true. How many students was it in that course?
Well, maybe it was a small class, man.
Okay. You know how many scripts I have to mark here, sir? About 50.
Years alone, sir. Remember, sir, you know, I did like a one course you teach, you know. Because when me check your schedule,
true,
so your
true.
schedule full for the whole week, so it's not
And
like a one set of class you have a mark.
and I am happy that again that the students are seeing all the classes for the last couple of in the first semester of last year I taught 5 courses. In second semester I taught 5 courses. And it's not 5 of the same course. 5 different courses. Different courses.
Oh wow.
Right? Yeah. And these are not foundational courses I'm talking about, chemistry and the environment, calculus 1, calculus. These are heavy courses. 5 different courses every day of the week, including Saturday. I was teaching. It was a rough school year. Including the summer, it was rough for me. But you will get it, man. I promise you, and I apologize. I'm not too big to apologize. I apologize for it taking out so long. But it is there are many scripts, and then day before yesterday, I got an email of some additional scripts for students who were proctored. Right? So it's about 50 something scripts that I have to mark. But I'm going to mark them this weekend. I'm finishing them off. The coursework grade is already done. That took a little while. So just think about it. I'm giving you 3 pieces of coursework. I mean, in one coursework, you're getting 3 questions. 3 questions times 50. And then another coursework. And then it's rough. It's rough. But I apologize. And on Monday, I promise you. All right. All right, so let's go. I am not seeing anything here where I can use as a hold on there. One quick thing. Let me just look on background meeting settings. Meeting settings. I see something here. Raise hand thumbs. Show my connection time. Stop incoming video. Portrait that in. Portrait lighting highlights you while dimming your background. Okay. Audio show meeting control. Okay, that's not it. I'm just looking at one more thing because I'm going to be doing a bit of revision now up until 1. And I want to. All right, let me look at the apps. Oops, there's none. All right.
Sir, this was a different. This was a subtopic on the limits that you did last night because I wasn't able to join last night.
Yeah, right. So this is another form of the indeterminate that we did last night. Yeah, man. Don't, Shauna. Sure, man. You're a good man. I'm gonna go through it now. You see, share notes. This teacher not just saying, okay, guys, do this, because I'm aware that some people weren't here last night, so that's why I am going to go through. All right, I'm looking, but I'm not seeing it. So you know what I'm going to do? I'm just gonna continue and see how best I can. How best I can. I have to go. I have to go change something about me. It may not be a good thing. From year group to year group, say, boy, say, Mr. Shan nice, but Lordy, miserable, sir. But me can't, in my old age, me can't continue my miserableness. So, so me for go, as of today, I'm not going to
I
be
had a
miserable.
comment, but I have to reserve it because I don't want it to cost me.
Leave me alone.
My granny always say, can I teach all dogs new tricks?
And you see, me so glad that Roderick is sleeping now because when him start, say can't
So so me not sleep me there. I try verify 2 titles for the director.
Oh, Jesus have mercy.
I do all kind of something. Sir, but me catch you have to catch part of what go on today, me not tell a lie. Last night me never clue to them, ever clue to them. Me can do right down to factorization. Only thing me don't know are what common and what left out of what. And if me not catch that, I can't get the answer. But me can when me know for substitution the function, all of that.
I see. All right, no problem. Quick actions. Let me see if quick actions I can get it. Quick actions. Sticky emoji dot 14. Highlighter. I think highlighter can give me a little. Let me see something. Quick actions highlight. No, come on, Sir Shan. You know. All right. Shauna, sorry. I'm here looking for something so I can. What is? All eyes on me. Popular tools into all eyes on me. What is below? Laser. You know, say a laser it is. A laser it is, you know. Laser. Want me to laser now? Rockstone. Want to see that on the screen?
Yes, sir.
No, but that not help me. Rockstone. Hold on there. I have to undo these. Because that not help me at all. Hold on there, guys. All right, Shauna, I'm very sorry. I was trying to find something smart drawing. No, not that. That not help me. All right, Shauna. You just have to go see if you can follow teacher here, mommy. I wonder if this Rockstone. Hold on there. What me do now? No, but if me do this, all right, hold on. I get in something that is a little. If I say this, it will highlight that, but we don't want that. All right, me go go and use this lasso, you know, until to see if it can go and work. All right, I find one little something, Sean. So I'm gonna see if it can work a little bit. All right, now, so last night what I did, and what I want you to do, students, is just to this. I should be able to go through this pretty quickly because I'm not writing. I want you to focus on what I'm doing here. I have just started and ended with you the indeterminate form 0 over 0. I've started with you the indeterminate form 0 over 0. What I'm looking at now with you is the indeterminate form infinity over infinity. That was a different example. This is it. The indeterminate form infinity over infinity. Then, sir, I did so much indeterminate form I have. We have 3. We did one last night, which is what I'm reviewing with you now. And we just did one a while ago. There's only one that is left. And that is going to be negative infinity over negative infinity. And I guarantee you that if you understand the positive infinity over positive infinity, that the negative infinity over the negative infinity is going to be the same thing. The only difference is one is going to be positive infinity and the other one is negative infinity. The concept work exactly the same. So if you understand, when you understand the infinity over infinity, trust me, I guarantee you, you must understand the negative infinity over negative infinity. Let's go. So I'm giving you a question. The question says the limit right here. So watch that. The question says the limit of x tending to infinity, right there, x tending to infinity. Can you see the highlight on the stuff?
Yes, sir.
All right, extending to infinity.
Sir, the screen, which screen? Me not see nothing, sir.
All right, somebody last night said you're supposed to do something like refresh the screen up at the top of your page. I don't know how it works on your side.
That's what I tell you, sir. That's the only way we can do it. So at the top of the screen, it says, well, for me, it says follow or following Mark Shand. If at any time that you actually go somewhere else, I have to click on rejoin, and which is almost like refresh, and it just carry me.
Oh, that screen that is almost orange.
Right. That
one. So yes, Roderick, because it's saying 15 people are following you, and there are 16 of you in the class. So you are not following me, Roderick.
That means he might have click to expand or to widen or to once you make any adjustment to the screen that's certain, it's going to stop following him. When you click follow, sir, you see every move he make on the screen.
All right. Me I follow you now.
Follow the leader. Good job. It still says 15, but never mind. You say I follow now. Good job. Thanks, Dalia and Romain. All right, let's go. So it says x to the 4th minus x squared plus 7 See it here, so this is something I talk about, the one in the numerator. And then down in the denominator now it says, can you see the blue arrow that I have right here now that I'm drawing?
I don't see no blue arrow now.
No,
Anybody
you
see
come
the
off
blue
the
arrow?
screen, you take it out of vision. You have to minimize your screen now, sir. When we're following you, if you zoom it up, it zoom up on our screen, right? When you zoom it out now, we're seeing it and we can see the arrow, whatever it is that you're doing now.
All right, so you see the arrow now?
Yeah, we're seeing where your cursor is, where what you're doing now.
Okay, all right, good. See, you're learning. Come and just learn that from, oh no, that's a teacher learn from students, very nice. So, Dahlia, you seeing where the arrow pointing now on the infinity over infinity?
They're not pointing anything,
You're not pointing nothing? I don't know this thing you're working, All right,
Sir,
come.
make on the blue asterisk. Make we see something.
Which blue asterisk? Drop on blue asterisk?
Yeah, so we follow where you there.
All right. You said blue, and is it true you said blue? Maybe it was blue.
All right, the part you're at indeterminate form with the infinite R. Yeah.
Right there, somebody there. All right, watch me now. Hold mouse, scroll to scroll. Navigate the canvas, touch screen. Mouse to scroll. Hold right click mouse. We still try find something for you. Auto trackpad. All right. Still not help me, but anyhow, I'll figure this thing out, All right, yeah. So where I'm at just now is where you see this blue thing. Where you see that blue thing? And so this is it. This is it. The limit as extends to infinity. No, infinity. And I'm going to start where I started last night. Infinity is a concept. Infinity is a concept. Because if you give me an infinitely large number, I can find a number larger than that number you gave me. I can find a number larger than you gave me. Are you following me?
Yes, sir.
Good. So what I'm saying to you now is x to the fourth. If I think of an infinitely large number and I raise it to the fourth power, I am going to get a much larger number. Let me use one as an example. And I'm going to use the number 2. And for ease of calculation, I'm going to use the number 2. Yeah, we know the 2 is not an infinitely large number because we could have got 2,000. All right, but we're going to use 2. But 2 raised to the fourth power is going to be 16. Look how far 16 is from 2. Talk truth.
Yes, sir.
Good. Just imagine if I'd used 10. 10 and 10 raised to the fourth power is 10,000. So if you put on $10, not that I support it because I don't believe in it. If you put on $10 as an invest, I was about to say lotto, but let me use investment. If you put on $10 on investment and you can get $10,000, that's a good investment, Because 10 the 4 from that. So just imagine if you put $100 down, what it would be if you raise it to the fourth power. So when I raise a number to the fourth power, it is going to be much more than what it was. Can you agree with that concept?
Yeah.
Yes, sir.
All right. Remember now, guys, I'm going just beg you about 15 minutes of concentrated time. Please. I'm going to send you this, what do you call it now? This
Whiteboard,
worksheet
yes,
here,
sir.
the whiteboard, right? I'm going to send it so you can look through this up. But just give me about 15 concentrated minutes now so I can just go through this example. Because once I go through the example, I'm not doing the whole examples, Once I go through one example, you'll recognize number 2 is the same way to number 2, is the same way to number 3, number 4, number 5, number 6, number 7. All of them are the same way we do them. So I just need to use about 15 concentrated minutes to go through this example so you can understand this. And then we'll have finished these 2 areas. Please. All right, so watch me. We have x to the fourth minus x squared plus 7. You know what? I'm going to bigify it because I want you to see what I'm talking about. X to the fourth minus x squared plus 7 all over 2x to the fourth minus 6x cubed plus 2. When I raise my infinitely large number to the fourth power, I am going to get a more infinitely large number. But I'm going to subtract an infinitely large number squared from it. That no matter. Because me still gonna have an infinitely large number. Think of it this way. 2 raised to the fourth power is 16. But 2 raised to the second power is only 4. 4 still the far from 16. Talk truth.
Yes.
So I will still have an infinitely large number. And guess what? When I add 7 to it, I still going to have an infinitely large number. So I can safely say that that number is going to be this infinity. That number, oh, come on. That number is still going to be this infinity. Let us look at the denominator. 2x to the fourth minus 6x cubed plus 2. I have an infinitely large number. I'm raising it to the fourth power. That means it's larger. Then we're going to multiply it by 2. I double it. And then what I'm doing, I'm subtracting 6 times that large number raised to the third power. I still going to have an infinitely large number. And then I add 2 to it, I'm going to still have an infinitely large number. So I have infinity over infinity. Notice, the only way the infinity over infinity comes around is when the function here tends to infinity. All right? I can't give you 0 over 0, the indeterminate 0 over 0 and get infinity. It has to be positive infinity or tending to negative infinity for me to have that. So I can say that this question is of an indeterminate form, infinity over infinity. So I write it. Infinity over infinity. So it's indeterminate. Oh, come on, man. So it's indeterminate. So look at it now. It's because it's indeterminate, remember, just like the 0 over 0, sir says, you have to do something, a small operation, a factorization, a rationalization, or a simplification. We're not doing any factorization for these ones. We're not doing a rationalization for these ones. What we're going to be doing is a simplification. How do I simplify it? I am going to be looking for the term containing the highest power, or the variable containing the highest power. Now, when you look at x to the fourth and then x squared in the numerator, you know, say x to the fourth is the highest term, the highest variable, or the variable with the highest power in the numerator. When I look at the variable with the highest power in the denominator, it's also x to the fourth. Can you see that?
Yes, sir.
Good. So because x to the fourth is a variable with the highest power, what I'm going to be doing is dividing each term by that variable with the highest power. So when you look at it now in the second line here, I'm dividing everything by x raised to the fourth power. Every single term inside of it will be divided by x. Even the constant, yes, even the constant is going to be divided by x to the fourth. It's going to be divided by x to the fourth. So every term in the question is going to be divided by the variable with the highest power. So every one of them is going to be divided by x to the fourth. And then I'm going to simplify. X to the fourth, as you see there, x to the fourth as you see here, x to the fourth is x to the fourth is divided by x to the fourth. As you see there, x squared is divided by x to the fourth. Can you see that?
Yes, sir.
And as you see there, the 7, right, is divided by x, right, I put in the dots, divided by x to the fourth. Shauna, can you see that, my love? Okay, good. Pen. Is pen still here, by the way?
Yeah, but me not understand. If me have
Why not understand?
true is the x to the fourth and you divide by x to the fourth, and then the next row now x square.
Divided by x to the fourth.
Yeah, but all right, go on. Let me hear what you say.
Hold on, Kim. Yeah, go ahead. Go ahead. It's all right. Just watch it. Just watch it, Shauna. Just watch it.
Okay.
Just watch it. Yeah. Just watch it. See here now. See here now. All right, Kim. Kim, yes, you can leave. We'll talk about it in the WhatsApp group. All right, Kim. I mean, Shauna, watch this now. So remember now, all of these are divided by x to the fourth. You can't say x to the fourth there. All of them divided by x to the fourth. Good. So what all I'm doing now is just canceling out. X to the, in the first one in the numerator, x to the fourth divided by x to the fourth leaves this one right here, so. All right? And then the second one now, this one here, x to the fourth, sorry, x squared divided by x to the fourth, everything in the numerator, because x squared is 2x, you know, is going to be divided by only 2 of them in the denominator. So I'm going to have 2 left, and that's why I put that 2 there in blue. I'm going to have 2 left. All right? Watch me now. In the third one, 7 over x to the fourth, I don't have anything to cancel out from the numerator. But in the denominator now, I have x to the fourth. I have x to the 2x to the fourth up here, so divided by x to the fourth. The x to the fourth cancel out. And all I'm going to be left with now is just the 2. X to the fourth cancel out, and all I'm going to be left with is just a 2. Can you see that?
Yes, sir.
All right. Huh?
No, I was just saying that I'm seeing it.
Okay, good job. Similarly, in this here one, the x cube will cancel with 3 of the x's from the denominator, leaving just 1 x in the denominator. So I'm going to end up with 6 over x right here, so, because it's only one of the x's got was remained right there. All right, and then the 2 over x now have nowhere to go. The 2 over x to the fourth is just going to remain as 2 over x to the fourth. So that's why I put it back here, 2 over x to the fourth. Similar to the 7 over x to the fourth, you don't have nowhere to go. That's why I put 7 over x to the fourth back here. So absolutely nowhere to go. And then no, this is the final part of it. As I was saying to students last night, and I'm using 1 as an example, if I have this 1 over x, when x is 2, remember, no, we're going to infinity, you know. So we'll move from a little bit as 1, and we're going to work ourselves all the way up to infinity. But we're going to look at the pattern. When x is 1, the fraction is going to be 1 over 1, which is 1. When x is 2, you're going to have 1 over 2. 1 over 2 is 0.5. When x is 3, you can have 1 over 3. That fraction work out to be 0.33. Then we say, oh, but I get smaller. And then you say, you know what, we're going to jump to 1 over 100. And you recognize it's 0.01. Blow, it really gets small. And then you try something now to see if I saw it go. And you try 1 over 10,000. And you say, ja. That gone to 0.0001 to get smaller. So I can say that as x tends to infinity, that the fraction is going to go to 0. Take a minute and look at that for me, and you will see that that is going to go to 0. As x tends to infinity, all of that is going to go to 0. Give me half a second. All right, so here what I'm saying now. As x tends to infinity, the 1 over x squared, the 7 over x to the fourth, the 6 over x, and the 2 over x to the fourth, all of those are going to go to infinity. Because once the numerator not moving, but the denominator is getting bigger and bigger and bigger and bigger and bigger, that fraction is going to go to 0. So all I'm going to be left with, really, is just this 1 over 2, and I can tell you that my answer is going to tend to a half. My answer tends to a half, and that's how we do all the questions. Trust me on it. All the questions that go to infinity, that's what and how it is that I've done this stuff. I'm going to be true to self. I did say to you that I'm going to end at 1. We really should start from 9 to 1. We started a little bit late, but guess what? It's a Saturday and I know people need to do the stuff. The truth is, I went to the market this morning and I need to go to the supermarket a little shortly from now. So what I'm going to do is I'm going to send you this stuff. You can look at this example. You can work it through. If you're having questions, students, just indicate. Just indicate and say, sir, I'm having a challenge. And let me know. I know some students left already, and I figured that these students left because they were with us last night and they understood this. May I get a recommendation? We need to have an early morning class because I also need to do this for School of Business purposes. Can you think about it and let us have and give me some feedback in WhatsApp? Think about it in your WhatsApp with the other students. I don't want to make a decision now because other students just left. As to when we will be meeting in the morning, please, it's very important that we get in as much work. Yes, we can get in some more Fridays. We can get in with Saturdays, but I'm going to need some weekday stuff with you as well to keep the communication going. And also,
we had already agreed on Wednesday, sir.
Yeah, but I think I need more than one day.
I need more mornings.
Yeah, man, that's the point. So Wednesday's fine, but I need another morning. That's the point I was making. You want us to try a Friday morning? No, because we're going to do Friday night, but we don't want to do it 2 times a day. Sorry. So Friday won't work. So think about it. You don't have to give me an answer now. Think about it, and we can have that conversation in WhatsApp so we can know. Because I need to chart something, which is what Mr. Bukumi asked me earlier on in class, but I couldn't respond to him because we never had that conversation. So talk to me and let me know so we can have our early morning sessions. But I am going to thank you, students, for coming out today. You know, I know that we've done quite a bit. And one early morning when I catch it fresh, I have one more. I have the negative infinity over negative infinity. I have the piecewise functions to do. And as soon as I do the piecewise function and the negative infinity over infinity, I will finish off. I'll finish off that. I just going to do. I'm looking at the outline. I'm going to do piecewise functions, and after piecewise functions, I am going to do. Wow, I won't have some multiple examples here, but after piecewise functions, I'll start the differentiation and integration, and I have to do multivariable functions with you as well. But I'll start the differentiation and integration. See, I see a business calculus question here. Not bad. I will do piecewise. I want to do piecewise one early morning and just finish it, start it and finish it one morning. Because yeah, and then now I'm gonna start the first principle. So there are two topics, two areas that I need to do before I start the differentiation, and differentiation is going to be the foundation of our calculus. Everything else that we're going to be doing now, we're going to be talking about differentiation and integration. All right, so let me know, keep me posted, because I mean we need to talk about the additional days. Thank you for coming out. Big up yourselves. Stay good. All right.
Bye, sir.
Bye bye. Bye bye.